In this lesson of nuclear fission and fusion, we have the following objectives. Each student should be able to at least differentiate between nuclear fission and fusion, identify equations for each of the reactions of nuclear fission and nuclear fusion, and then set conditions for nuclear fission and fusion to occur, as well as stating the applications of each. So you're welcome once again to this lesson. Let's begin by watching this video here.
When a neutron is fired at high speed into an atom of uranium, it will split the atom in a process called fission. The stability of the nucleus of an atom is maintained by the balance between the repulsive electrical force among protons and the attractive nuclear forces holding the nucleus together. With uranium, this balance is unstable. Thus, when a fast-moving neutron collides with the nucleus of uranium-235, it is stretched into an elongated shape. This elongated shape tips the balance in favor of the repulsive forces, and the uranium-235 atom splits into fragments of krypton and barium. 3 neutrons are also generated from this powerful release of energy. The 3 forcefully ejected neutrons can each strike an atom of uranium, resulting in the case of an atomic bomb, a catastrophic chain reaction. The nuclear fission process is also the source of energy used to operate nuclear power plants. In a controlled environment, the tremendous heat generated by splitting uranium-235 is used to produce steam that drives turbines to generate electricity.
So from that video, we can begin our lesson by looking at nuclear fission. So how do we define this? We simply define this as the splitting of a heavy radioactive atomic nucleus with the release of energy. In other words, the nucleus of the radioactive element or atom is unstable, and once conditions are available and it splits up into 2 or more atoms, then we call that one nuclear fission. An example is we have this diagram here of the nucleus of the atom, whereby if a neutron comes and collides with it, we see that that atom is going to split up into 2 other atoms. And an example of this is when we are splitting uranium-235. And once this has been split up, it forms barium and then krypton, as you've seen in this equation here. So in this equation, we are producing 2 neutrons. In other words, for nuclear fission to occur, there must be an accelerating or a moving neutron which collides with the nucleus of the atom, and then it splits up to form other nuclei. Now, in this example here, we have this X here. The question is, how do you find this X? Remember nuclear equations, alpha decay, beta decay, and then gamma decay. We talked about this. So you can pause the video and find out this value of X. Okay, so that in case we're going to find out that value of X, what we do is simply balancing the atomic mass and then the atomic number on either sides of the arrows. So beginning with this arrow here, we can simply say that for the atomic mass, we can say that 235 plus 1 is equal to 236. So this is okay. And then 92 plus 0 is equal to 92. So this one is also okay. Now you go to this other arrow here. You can say that for the atomic, this is atomic number. For the atomic mass, we shall say that 236 is equal to 144 plus y plus 2 times 1. What does this give us? It will give us our y as 90. So that is for the atomic mass. And then for the atomic number, shall simply say that 92 is equal to x plus 36 plus 2 times the 0. I know that remember all of this. So simplifying this, we shall find our x being equal to as 56. So whenever you see an equation where you have a neutron bombarding the nucleus of another atom, then that is going to lead us to nuclear fission. In case you have, like we watched in the video, in case you have one neutron colliding with the nucleus of one atom, it may lead to two or more atoms, neutron nuclei. And once those neutron nuclei are also hit by other neutrons, then you form other smaller nuclei. In other words, the process leads to what we call a chain reaction. And this means that very many other delta nuclei will be formed as more and more neutrons are colliding with those nuclei there. So meaning therefore that we form what we call a chain reaction. Now, if this reaction is not controlled, then that is applied in atomic bombs. Otherwise, if it is controlled, then it can be used in what we call production of electricity using the nuclear energy in the nuclear reactors. So that's about nuclear fission. Some of the conditions for these are basically: one, it occurs at low temperatures, then there must be presence of neutrons and the presence of the unstable nucleus or nuclei, in case there are many. Those are the conditions for this. In the production of electricity using the nuclear reactor, I can just talk about it briefly. So in the nuclear fission reactor, in other words, in the production of electricity, the reason as to why you have nuclear fission is simply to provide large amounts of energy, which energy is used to heat up the water, and this water, after being heated, provides the steam, and the steam runs the turbines, which leads to the production of electricity. In short, that is how it works. Now, turning to nuclear fusion. What is nuclear fusion? The word fusion simply means joining, it means combining. So simply define nuclear fusion as the combination of two or more light nuclei to form a heavy stable nucleus. And the marking words here, the most important words here is that light nuclei combine and they form a heavy stable nucleus with the release of energy. That is what we call nuclear fusion. This process takes place in the sun, stars, and in the hydrogen bombs. That is where it takes place. Now, an example here is, for example, in the sun, two hydrogen nuclei, the one that we call the deuterium, these are isotopes of hydrogen. They combine to form a helium gas and neutron. And this process takes place when there is too high temperatures. So this is our equation that we have now. Remember that in nuclear fission, we say that one atom, or the nucleus of one atom, is bombarded with a neutron. This time around, we don't have neutrons. So simply have light nuclei combining to form a heavy one, plus energy, of course. Now, balancing our equation as usual, for the atomic mass, we have 2 plus 2 equals to 3 plus 1, which gives us a 4. So this one balances. The atomic number as well, 1 plus 1 is equal to 2 plus 0. So that one also balances. That is a balanced nuclear reaction equation. And that is for nuclear fusion. Now, the conditions for these are: one, it occurs at very high temperatures of about 10 power 8 kelvins, very high temperatures. There must be presence of two light nuclei. And then lastly, it requires that these nuclei here must be moving at a very high speed. So those are the conditions for nuclear fusion to take place. And like I've said, that the applications or the uses of this process is that nuclear fusion is responsible for the production of energy in the sun and other stars. And then in the process of the hydrogen bombs, how do the hydrogen bombs work? It is also about nuclear fusion reactions. So with this, I come to the end of nuclear fusion and the fission reactions. Next is a quiz for you in the next part.